A matrix multiplied with its inverse always results into, if A is invertible, then inverse of A to the power k will be equal to, then what will be the value of determinant of B, A inverse B transpose. Dear students, welcome to Alan Overseas. Let's continue with our special series. This series will cover 45 important topics in 45 days. It will be really helpful for the JEE Mains aspirants. So let's start. This is how the topics are going to be distributed between physics, chemistry and mathematics. And I am going to take mathematics for you all. So let us begin with our today's topic. Today we are going to discuss about the inverse of matrices. This comes from the topic of matrices. So what is inverse of a matrix, or we should say reciprocal matrix? Inverse of a matrix is also called as the reciprocal of the matrix. Now the condition for a matrix to be invertible means inverse of a matrix exists if the given matrix is non-singular. The matrix should be non-singular to be invertible. According to definition, a square matrix A is said to be invertible or non-singular if there exists a non-singular matrix B such that A into B, when we multiply both the matrices, it results into I, that means an identity matrix, where A and B are called the inverse of each other and is denoted by A inverse is equal to B, or we shall say B inverse is equal to A. The inverse, if I am writing A inverse is nothing but adjoint of A divided by determinant of A. Now obviously, if determinant of A is equal to 0, then A inverse cannot exist. So that is why we said that A should be a non-singular matrix. Right? Now A multiplied with A inverse, a matrix multiplied with its inverse always results into identity matrix. Right? So identity matrix is also equal to matrix multiplied with its inverse. Right? Here also, if we are using A and B such that A into B is equal to I, then B into A will also be equal to I, which I means an identity matrix. Look at some properties of inverse of a matrix which help us to solve the questions, which are really important for solving the questions. The first point as mentioned, that A inverse, the inverse of matrix A, is adjoint of A divided by determinant of A. Here determinant of A should not be equal to 0, that's a condition. Right? We have already defined that A is a non-singular matrix. Now, if A is invertible, then inverse of A will result into A only. Suppose A is an invertible matrix and inverse of A will again result into the same matrix, which is A. If A is an invertible square matrix, then A transpose is also invertible. This we should know, that if A is an invertible matrix, if we can invert A, if we can find the inverse of A, then transpose of A is also going to be invertible. And A transpose, inverse of A transpose will be equal to transpose of A inverse. Either we take the transpose of A and then find its inverse, or we can just find the transpose of A inverse. We can first find the inverse of A and then find its transpose. It will be the same thing. If A is a non-singular matrix, then determinant of A inverse will be equal to the inverse of determinant of A. Or we can also say that determinant of A inverse is equal to 1 by determinant of A. This is a very important point over here. Now, if A is a non-singular matrix, then again adjoint of A inverse will be equal to adjoint of A and its inverse. Either we find A inverse and then find its adjoint, or we find inverse of adjoint of A, it will be the same thing. If A is invertible, then inverse of A to the power k will be equal to A inverse to the power k, and it will always be equal to A to the power of negative k, negative integral power of A. That means negative integral power of A. Now along with this, we should also know some properties of inverse of matrix along with some properties of determinants to solve some questions. We should know that determinant of A multiplied with the transpose of determinant of A will result in the square of the determinant of A. We should also know, if I am writing determinant of A and B, where A and B are two invertible matrices, then it will be equal to determinant of A multiplied with determinant of B. This is the same thing. I should also know that determinant of A inverse will be equal to 1 by determinant of A. This we just now discussed, and these are the properties we are going to use to solve a question which has appeared in JEE Mains 2019. Here, A and B are two invertible matrices of order 3 into 3, and if determinant of A transpose and B is equal to 8 and determinant of A B inverse is equal to 8, then what will be the value of determinant of B A inverse B transpose equal to? Now, first of all, we'll write down what is determinant of A, B and A transpose. We can also write it as determinant of A transpose and B. We can write it like this: determinant of A transpose multiplied with determinant of B. Now, determinant of A multiplied with determinant of A transpose will become determinant of A and square multiplied with determinant of B, and this is given to us equal to 8. Now, the another equation which is given to us is determinant of A and B inverse. So, determinant of A and B inverse, we can write it like this: determinant of A multiplied with determinant of B and its inverse. Now, this can be written as determinant of A divided by determinant of B, which is equal to 8. So, this gives us determinant of A equal to 8 multiplied with determinant of B. Now, this is our second equation, and we can put it into this one, which is our first equation. Right? The value of determinant of A we can put from here. So, this is going to become determinant of A square, that means 8 into determinant of B whole square. So, it will become 64 determinant of B square multiplied with determinant of B, that means determinant of B whole cube, which is going to be equal to 8. From here, I am getting determinant of B equals determinant of B whole cube equals 8 divided by 64. That means my determinant of B is going to become 1 by 2. Now, my determinant of B I've got equal to 1 by 2. So, from here I have to find determinant of B A inverse into B transpose. So, now this term I can write it as determinant of B multiplied with determinant of B transpose multiplied with A determinant of A inverse. Now, this will come out to be determinant of B whole square, because determinant of B multiplied with determinant of B transpose is going to be determinant of B square, and determinant of A inverse will be 1 by determinant of A. Now, I know my determinant of A square. Now, I know my determinant of A was equal to 8 multiplied with determinant of B. So, this is going to cancel one times. So, now I'll have determinant of B divided by 8. And determinant of B is 1 by 2 divided by 8 will give me 1 by 16. And this is going to be my final answer, which is option 2. You can see how easily we could solve this question using the properties of inverse of matrices and determinants. So, that's all from my side on this question. Don't forget to watch the complete series, and if you still have any more queries or suggestions, then feel free to reach out to us in the comment box. Stay tuned with us. Thank you.